Our project is maglev elevator. We are last year students in mechatronics engineering in Yıldız Technical University.
Problems with current elevator technologies. There are obvious disadvantages in today's elevator technologies. According to Mitsubishi's research, if you want to build an elevator system in a 100-story building, 30% of the building area goes to the elevator system. In addition, there are comfort problems and security weaknesses caused by vibrations caused by the rope system and rails. In addition, a standard elevator cannot exceed 10 meters per second speed due to these vibrations. There are 2 elevators in the world that can exceed this speed. These elevators are specially produced for speed, very costly and difficult to manufacture. And also mass production of these elevators cannot be made. The height of the buildings is inversely proportional to the spring coefficient of the steel rope. This causes the elevators oscillate vertically in high buildings. Another source of vibration is rail systems. Horizontal swing occurs due to surface unevenness and connection points during the production of elevator rails. These vibrations reduce the speed limit of elevator systems considerably because they reduce comfort and make control difficult.
In the previous attempts to solve these issues, they made a tower in Yokohama, Japan, the Yokohama Landmark Tower. While the elevator of the Yokohama Landmark Tower was being built, significant changes have been made to the rail system to reduce vibrations. In addition, the control elements of the electric motor are carefully calculated and manufactured from expensive components. With these improvements, it can reach a maximum speed of 12.5 meters per second. The graphics in the image are made from the data obtained during the operation of the elevator. In another attempt is ThyssenKrupp's Multi. The company ThyssenKrupp, on the other hand, removed the ropes from the design and designed a system consisting of single-sided rails instead. In this way, it provided a reduction in the area of the system and made it possible to move in 2 axes.
Now, our solution. We aim to achieve higher speeds by using magnetic levitation technology, getting rid of rope and mechanical movement systems, eliminating horizontal and vertical vibration and discomfort. In addition, due to the lack of mechanical movement systems and machine room, a considerable saving is provided. Thus, it is possible to use more than one cabin in a single elevator shaft in the future. Deep dive. Target altitude information is sent from the computer to the controller. The controller processes this information and sends a signal to the motor driver. The motor driver creates a current according to the signal and transmits this current to the linear motor. Moving magnetic fields occurs on the linear motor according to the incoming currents. The magnets on the cabinet interact with these moving magnetic fields, allowing the cabin to move. With the help of sensors, position and bearing air gap are sent to the controller as feedback. In this way, errors during movement are minimized. Inside the controller, the bearing air gap and vertical position control of the elevator base are performed, while the horizontal vibrations are minimized by magnetic bearing. With the bearing air gap control, the floor control of the elevator and vertical oscillations are controlled with the vertical position control.
How does magnetic levitation technology work? First, what is magnetic levitation? Magnetic levitation is the holding and moving of objects in the air without mechanical contact by magnetic field forces. In our system, while the cabin will remain balanced with magnetic attraction, it will be moved vertically using this principle. This principle is often used to keep it balanced vertically and move horizontally. Example of this can be seen on maglev trains as well as in our school's work at the ASIL lab.
How does our project work? By controlling the horizontal air gap with hybrid U magnets, it provides stabilization during the linear movement of the cabin during non-contact movement. The movement of the cabin in the vertical axis will be provided by linear coreless synchronous motors. With the help of distance sensors, the magnetic bearing gap will be continuously measured and controlled to keep it constant. For the outputs of our system, the acceleration will be 2 meters per second square. The load capacity will be 3 kilograms. 1 meter maximum height, 13.5 meter per second maximum velocity, and 1 millimeter air gap.
Know-how development. Today, there are already maglev applications that work well on the horizontal axis. However, thanks to this study, we are planning to establish a basis for future studies by proving that this system can work stably also vertically. In addition, movement in two axes can be made possible with the help of some changes to be made on the system.
Time management. The Gantt chart you see in the figure is a visualization of the start and end dates of the work packages created for the realization of the project. Completing the work packages of the project within these time intervals will prevent disruption of the project.
Our sponsors and facilities. We are planning to create a financial resource for our system through the TÜBİTAK 2209B support program. In addition, we will create additional resources by applying to the competitions of companies such as DHI for our product. Alarge will provide consultancy and equipment support during the production stage. ASIL Lab will provide with their research equipment and research facilities. In addition, we believe that the facilities of our school will be sufficient for testing and production. For potential problems we may encounter in production, we will work with new stakeholders who can find solutions for our problems.
And expectations. TÜBİTAK expects us to form an industry-oriented project following their guidelines. ASIL Lab and our consultant expect us to create a know-how and report regularly and clearly for the future work. Alarge expects us to use maglev technology in different areas to find new uses for it in the industry.
And thank you for your time and considerations. If you have any questions, you can ask right now.